let's quickly move on to the next speaker so we can focus all our time on the talks. Jonah, welcome.
Hi, I'm Marilag and Barbara. Nice to meet you and great to be here. Thank you for having me.
It's so great to have you as a speaker here. Awesome.
Yes.
You're joining us from Sweden also, right?
Yes, I'm in Sweden.
Awesome. Yes. Well, no further ado, just take it away. The floor is yours.
Yes, sure. All right. Hi, everyone. Today I will be sharing about the different patterns of Azure durable functions. And I hope to do this quickly within the next 25 minutes so we can also have some questions. So before I start, I want to introduce myself. I'm Jonah. I'm a software engineer. I code full stack .NET development. I work at Forefront Consulting. I'm an Azure developer, Microsoft MVP, and a technical trainer, and the founder and co-organizer of Azure User Group Sweden, a local user group here. And today I want to talk about a bit about durable functions, Azure functions, the different patterns. And I wanted to show a code demo, but I don't think we will have time for that. But I will show you some use case example later at the end if our time permits, and then some recommended learning resources. So I want to start my talk by sharing with you about this problem, the airport queue problem. So since COVID, as we all know, we've been working from home for the past year. And I know that we miss traveling, but definitely when the world opens up again, we're going to be experiencing airport queues. And definitely there will be long lines and when we ended up in this queue, sometimes we wish that we could do something else, like grab a coffee, relax at the airport, and just use the self-service airport, machines. But then sometimes we cannot control that, and it can be challenging. And my point here is also for that airport queue is that about programming. In programming, we experience concurrency problems. And when I was studying Java development years ago, I encountered this problem. It's called the diner philosopher's problem, in which the scenario is that there are 5 philosophers and 5 forks. And the scenario is this, each philosopher needs both forks, left and right, in order to eat. Otherwise, they can't. Each of them can't. So the problem here is related also to programming. For example, in this case, for the dining problem, there will be an issue with the deadlock, which means that if one of the philosopher picks both left and right, then no one can eat. And if no one can eat, then that means they can die of starvation. So this is the reason why I want to point out as well that in programming, we experience a problem of concurrency, racing conditions, and deadlock. And I believe that the solution for this would be serverless, especially right now I'm talking about Azure functions or durable functions. And I, as a developer, I love serverless because I can solve complex problems. I can build modern apps, and it makes me productive as a developer. So I love serverless. So I want to give you a brief overview what Azure Functions is. So it is a serverless compute in Azure. You can have it on demand, and you can pay as you go, pay only for what you use. And it is event-driven, function as a service. So it's perfect for event-driven apps or architecture. And as a developer, you write less code. And that means you also get developer productivity, which means for us developer teams, we don't need to worry about maintaining the servers or maintaining or upgrading the infrastructures behind it, because the cloud provider, Azure, takes care of that for us. And of course, just like the previous session, we had a lot of sessions about integration with Logic Apps, Azure SQL, and Cosmos DB. Azure Functions integrate very well with Azure APIs and services, as well as external APIs. So basically, Azure Functions is composed of the logic that we have in our function app, the code, and also the events, which are the triggers that we use, HTTP or blob trigger, and also the data, for example, the bindings, the input and output binding. So that is Azure Functions. So what are durable functions then? So durable functions are extension of Azure Functions. So it allows us to write stateful workflows in serverless environments. I know that logic apps can allow us to do that as well, but in durable functions, we do it more in the code. So it's more code-driven in the logic. And it's also a compute service. What's good about durable functions is that it manages and checkpoints and even restart the state for us, and we don't need to do that. And the technology behind durable functions is the durable task framework, which you can check actually on GitHub through that link. So, and also it supports different languages like C#, JavaScript, Python, F#, and PowerShell. And now let's go to the different types of durable functions. So there are different types. There are 4, but the top 3 are like the client functions, the orchestrator functions, and activity functions. And the last is entity functions. So client functions are like the starter functions. They kickstart the orchestrator. It is the starting point of the orchestrator. It can be an HTTP trigger, a blob trigger, service bus trigger. And then we also have the orchestrator functions. In orchestrator functions, that's where you describe your actions, your workflow, and how you want your tasks or functions to be executed. And we also have activity functions. So activity functions are like the normal Azure functions, actually. They contain the basic unit of the workflow, like the task that needs to be done. And activity functions can only be triggered from the orchestrator function or through the workflow. And then next we have entity functions. And entity function types are used to define operation for updating small pieces of state, like it's also called durable entities. And the difference between the other types and entity functions is that you need to use entity trigger. And it's supported from durable functions version 2 and above. And I think it supports .NET and JavaScript, and I think Python recently. And what differs Azure functions from durable functions? So Azure functions are stateless and durable functions are stateful. And this is a big difference, because sometimes I get a question, what's the difference between them if they're like extensions or about the same? So these are the big difference between the two of them, but they're there to help us in providing solutions in our different use case scenarios in organizations. And one of the most important type in durable functions are the orchestrator functions. So the orchestrator, it needs to be designed or coded properly, because it is deterministic. And it is important to be determined in your design in the workflow, because the orchestrator function will be replayed. And if you want to learn more about deterministic API, you can check out the link on this presentation to learn more about the details of how it works technically. And here is an example of deterministic versus non-deterministic. So here on the left, we have the durable functions with an orchestrator, a determined orchestrator, which has a workflow for all its activity functions. And then on the right, we have isolated group of Azure functions that has no orchestrator. And the difference here is that, for example, if the VMs of one of the functions here on the right, without the orchestrator, gets restarted, then there's a possibility. There's a possibility that you will encounter some problems because it can be a state. It loses its state when the VM is restarted in Azure, and we also have three things to think about when we're designing our orchestrator. And there's a code constraint documented in MS Docs, the do's and don'ts. For example, when you design your orchestrator, it is recommended not to generate undeterministic list of things. So for example, grid, they are random, and like blocking APIs, infinite loops, and current datetime. Of course, the time ticks all the time, so it's not really like constant. So what is recommended instead is the do's. For example, for grids, you use a new grid method. For configuration, you pass it in your activity functions. And if you really need to use like threads, you can make use of the functions available through the context. And if you really need to do a loop within the orchestrator, then you can use the create as new method. And there's also a specific function for the datetime. And I want to introduce you to the first pattern, which is called the function pattern. So function patterns execute a sequence of functions in a particular order, like a chain. So like this. So we have function 1 that pass in a parameter or data into function 2, and a function 2 pass in that result or output to function 3, and a function 3 pass in that output to function 4. So the output of function 1, for example, is required as an acquired input to function 2, and so on. So in action, it looks like this. So for example, if you have HTTP trigger or blob trigger, the orchestrator gets started. So when the orchestrator gets started, the activity 1 is scheduled, the orchestrator sleeps, activity 1 is done, orchestrator wakes up, activity 2 is scheduled, it sleeps again, and then activity 2 is done. The first orchestration is completed. And that continues as long as the orchestration is long running and it's triggered. So the good thing about this is that when the orchestrator sleeps, you don't really get charged for those activities or functions that are not running. So that is very good when it comes to consumption or cost perspective. And here is an example of a hello sequence in the documentation for function chaining, where you have like a hello sequence to say hello to the different cities like Tokyo, Seattle, and London, and return the rest of the output. And then the next pattern, the second pattern, is fan out and fan in. So this is how it looks. So in fan out and fan in pattern, you execute multiple functions in parallel, wait for all the functions to finish, and then aggregate the result as one when all of those parallel tasks are done. And this is how it looks in code, for example. So here we have an example that we can back up site content. And we have files that we need to back up and loop through the tasks for that backup. And it uses the method task when it does its fan in, when all of those tasks are done. And then it returns the result. And the third pattern is async HTTPI pattern, which is a very common pattern or useful when you want to solve problems in stateful long-running operations, especially with external clients. So here is an example. So here, I hope the screen is okay. It should be white, but anyway, I have a function here that's called check if website is available. It's in .NET since I'm a .NET developer, and what I have here is that I have a try catch block with an object called durable HTTP response, and in here marked in blue, I use an await method to call an HTTP async method passed in the method that I need, for example, get my URL, and I have an if condition that check if my website has the status code or code that are good, then I get the content of my HTTP response, which is a durable one, or I throw in an error as log. And the next pattern is monitor pattern. So monitor pattern is the opposite of HTTP async API pattern, because this one is different. It is useful for recurring process that can be flexible in a workflow. For example, you can use timers to monitor a certain workflow. For example, this one, monitor pattern. You have a function here called monitor job status, in which you have an expiry time for your monitoring, and a while loop that keeps checking if the status is completed, and it's going to call the activity called send alert, passed in the machine ID, and then the orchestrator keeps on will sleep until the next check or expiry time. And then the next pattern, the fifth pattern, is the human interaction pattern. So sometimes we need to solve problems that requires human interaction. So for example, this one, the approval process workflow. So a function needs to send requests for approval to a human being or a person. But sometimes a person, for example, a manager that needs to approve something is not there. Maybe he or she is on the vacation and it can't answer right away. So this is the reason why you can also add a timer to automate the process. So here, for example, we passed in a request for approval, and if the person responds, then process the approval. Otherwise, after a certain time, you can also escalate it or do something else. So this is how it looks in code example. So you have a method here. You have a timer, durable timer, and you also have a method called wait for external event from the context to wait for the response from a human being. And the last but not the least, one of the patterns is the aggregator pattern. This is commonly used for stateful entities, or where you aggregate the event data over a period of time as a single entity. And this event data can come from different resources, and they can come anytime. And the aggregator aggregates or handles them as they come. And this can be tricky to fix in a normal function, because in a normal scenario, you would need to send it in a certain kind of queue, and then you need to keep checking on the queue as well when the trigger comes in or the message comes in the queue. So with aggregator pattern, you can solve a lot of problems that could make use of this one. So this is how it looks in the code example, code snippet. So you have the iDurable entity context, and in the context, you can call get input with the value of integer, set state. And then here you can, on the right side, you can also signal, you can also use signal entity async and pass in your entity ID in here, and the method as well, and the data. And there are more information about durable entities on this link, so you can dig deeper into this and how it can solve your scenarios. And then it is also possible to add sub-orchestration within an orchestration in durable functions. Right now, I believe it's supported only in .NET, JavaScript, and Python. So this is a really good one if you have more complex use case scenario. And this is how it looks in code. A simple example, you use the context and then you call the method named call sub-orchestrator async method. And then you also use the method when all from the task to get the results. So for developer perspective, when you want to develop functions, it's recommended to use this tools. So we have, of course, our favorite tool. You can use Azure Portal, the CLI, Azure CLI, Visual Studio, and Postman, Storage Explorer, and the supported languages. And I wanted to show the code, but I think our time is limited. So I want to show you how my flow looked like in my sample app. So I have here a simple function chaining example. It's like a notifier for when I upload a message into a blog, it notifies me through SMS or call, and it integrates with Azure Service Bus as well as Twilio API and SendGrid. So here's the flow looks like. So I have an Azure blog trigger, which is my client function, the starter function. And then it kickstarts my orchestrator, where I have my workflow, which is the function chaining. And then I passed in my blob image data into my first function, which creates and sends a message to the service bus as a queue. And then once it's done, it's going to send an SMS call to me as the administrator of that Azure storage with the help of Twilio API integration. And then when I'm done with sending SMS and call, I will also send an email notification that an image blob was sent with the link to the image that can be accessed on the browser. And that uses SendGrid. And the expected results would be like this. So I received an SMS on both my iPhone and my watch. And then I receive a call. And then I also received an email. So if you want to check the simple example, I have it on my GitHub through this link, since I can't do live demo and because of time. And then next is I want to share with you this use case that I'm proud to be part of and to contribute. It's the serverless, the power of serverless for Azure's cloud security. It's called Cloud Katana by Roberto Rodriguez. So I believe one of our hosts, Barbara, is also helping in this project. And what it does is that it uses Azure functions, specifically durable functions, to simulate attack and defense in the Azure environment. And it's really a great project right now because security is something that we missed. We take for granted sometimes when we're developing. And I, as a developer, believes that cloud security is important. And it's good that it's also open source, open to everybody. So if you want to contribute, you can also check out the links in that. And as for learning resources, we have, of course, Azure Functions, Microsoft Learn. We have Azure Functions University by one of our speakers as well, Mark Ducker, and also the Durable Function Extension. And I want to thank you, everyone, for listening. And if you need more info, feel free to connect on LinkedIn, on my website, or Twitter. Thank you.
Awesome. Great story on Azure Functions. Yeah, and that's true. I was also part of that project. So yeah, I'm a bit biased. Yes. I really love what we did over there.
Same here. Yeah.
Yeah, I know that you did great job, especially with the PowerShell. And And now I think it's planned to be translated in different languages.
Yeah, and actually for PowerShell, the durable functions are relatively new. So it's great that he made use of it that way.
Yes.
Okay, well, most of the questions were lined like, where can we find this presentation? Because really people love the presentation and all the information on there. And it should be part of the recording later on. But you also gave all your contact info, and I'm sure people can approach you.
Yes, yeah. I can share the speaker deck file for this presentation. And the audience can feel free to connect with me if they have follow-up questions after this, since we have limited time.
Yeah, it looked really great. It was really informative. So awesome session. Thank you very much for that.
You're welcome.